And the recording will be available on our website www.Oges.Info. We'll be launching few posts for the audience to participate. The results of the same will be shared during the webinar. Oges is a portal for oil and gas questions and answers, opportunities, projects and jobs, and we have a best question and best answer award for every month. This event is covered under that event. Few selected entries from this webinar registrations will receive free trial access to our premium plan. For others, they may request a code by mailing to support@oges.info. You may also request any training on any of the oil and gas domain to our support team. In case you lose any connection, get back to us through the same invite mail from GoToWebinar. There might be some time lag when we change the slide or the presentation. Please bear with us. Would love to hear from you. Send us your feedback on support and don't forget to fill our survey when you make an exit from this webinar. Let's meet our speakers in the waiting room. We have with us Dr. Christian Mugensen, who is an EOR Technical Advisor at ENI Milan. Dr. Christian is an MSc and holds a PhD degree in Chemical Engineering. And he has led the R&D efforts in master oil and leading R&D efforts in conventional enhanced oil recovery methods. He is a master in methods like gas injection, chemical flooding, nanoparticles, and genetic engineering. Then we have Holger Kringer, who is the owner and founder of Planstay Engineering and Consultancy Services from Germany. He holds an experience of more than 30 years in this domain. And he'll be talking about well integrity challenges in drilling and completing wells for EOR. Then we have Rajesh Sharma, who is an expert in setting up production facilities and business transformation of E&P upstream, leveraging digital oil field and analytic technology. He has an experience of 32 years in oil and gas, and he'll be throwing light on digital approach to EOR. Then we meet our last panelist on the board, Aninda Ghosh. Aninda is working as a geologist in NTPC, and he has a good amount of experience in reservoir data acquisition and interpretation, planning, conducting well testing operations, field development planning of onshore and offshore fields, and reservoir characterization. He'll be throwing light on EOR screening studies and EOR applications in India. So this is our panel, and we start with Dr. Christian. Dr. Christian, the stage is yours.
Thank you very much, Namrata, and I hope everyone can hear clearly what I say. We begin with the basics of EOR, why and how. The typical situation when you embark on an EOR project is that you have already water flooded your reservoir. So now you're looking for ways to improve the recovery. What you can do is you can change the fluid properties, you can change the way the fluids interact with each other in the reservoir, or you can change the way the fluid and the rock interact. But when you talk about recovery, there are actually three components. There is the microscopic sweep, there is aerial sweep and vertical sweep. And the EUR or methods that we will be talking about, they typically are focused on doing one or maximum two of these contributions. EUR is typically applied to fields, so where you have depleted the field or water flooded it for maybe 20 years, and you typically use EUR for onshore reservoirs because it's easier to get access and therefore also cheaper. So if we move to the next slide, we will look at the first EUR method, which is gas injection. So the purpose of gas injection is mainly to improve microscopic sweep. So gas can become miscible with the reservoir oil, and it can swell the oil so that the oil saturation increases, and hence the oil relative permeability also increases. At the same time, the oil viscosity will be reduced, typically by a factor of 2 to 3. But you can also improve the vertical sweep because gas is much lighter than oil, so it will move towards the top of the reservoir, and it can sweep areas that the water did not sweep. And of course, you can also achieve pressure maintenance, but that's not an EUR method. So gas injection is typically applicable to medium to light oils. My colleagues from India will later show you the various screening criteria for the various EUR methods. But there are a number of challenges with gas injection. First and foremost, the overall sweep is actually poor. You get early breakthrough. This means you have to handle more gas. And that happens because gas is lighter than oil, so you get gravity override. And gas is also much less viscous than oil, so you can get viscous fingering. In both cases, you get early gas breakthrough. Another complicating factor is the phase behavior, how exactly the gas develops miscibility with the oil. It requires lots of lab testing, and it requires what is called an equation of state to capture this in a simulation model. Also, what you need to be careful with is flow assurance issues. Gas and water can, under certain temperature and pressure conditions, form hydrates, and gas can also cause asphaltene precipitation from the oils. Then final thing on this slide is some safety aspects. I know Holger will talk more about well integrity and corrosion. These aspects are very, very important. So in order to mitigate some of the poor sweep, people invented about 50 years ago the water alternating gas, or WAG injection. And in essence, you inject cycles of gas and water, and then you get the benefit from both, and you limit the problems with early gas breakthrough. Now, it's actually complicated to model, but I would say nowadays WAG is the preferred method for injecting gas. If we move on to the next slide, second very important EUR method is polymer injection. And here you're not interested in reducing microscopic residual oil saturation, you are looking at improving the aerial sweep. So here we're talking about either, so you increase the water viscosity, and time you can compensate to some degree for permeability contrasts in the reservoir. So even if you have a light oil, you could still see benefits from injecting polymers. The challenges with injection is that the rheology is complicated. So again, you need lots of lab experiments, the modeling is difficult, and the logistics are tricky, especially if you are operating in a remote area. How do you get your chemical to the site? At some point, the polymer will break through to the production wells, and it will affect the oil-water separation. That can also cause problems. When you increase the water viscosity, it's clear that the injectivity will be reduced. That can also cause problems. So you will be able to inject 4 barrels per day when you start injecting polymer. So your throughput will be reduced. Polymer can also be combined with surfactants and alkali in the so-called ASP process. That one is probably the most difficult to manage, and it's mainly carried out in China. Finally, you need to keep in mind that polymers are not very tolerant to multivalent ions in the water, such as calcium and iron, and it's also not very tolerant towards temperature. So moving on to the third main EUR method, which is thermal. The most common thermal method is steam injection. And here the idea is will condense when it reaches the reservoir, so the heat of condensation is carried over from the heat from the steam to the oil. So you are able to reduce the viscosity of the oil by a factor of 1,000. Typically, steam cannot be applied to depths larger than 2,500 feet, because then the steam starts to condense in the wellbore and you lose the heat exchange. So moving on to the next slide is a variation of the steam injection process called cyclic steam, where you essentially, you still inject steam, but then you back produce oil through the same well. So you would be looking at injecting for, let's say, a couple of weeks, and then you would have a soaking phase and you would be back producing. Another method on the next slide is a Canadian specialty called steam-assisted gravity drainage, or SAGD. And this technology relies on drilling 2 horizontal wells very close to each other, about. So you need very accurate well placement skills. And then you inject steam in the top horizontal well, and it creates a steam chamber that pushes oil towards the bottom well. It actually works. And I would not be surprised if there are also SAGD wells in India. The final thermal method is on the next slide. It's called air injection, or in situ combustion. And you can inject either air or oxygen, and the purpose is to burn a little bit of the oil to create also a heat chamber that reduces the viscosity of the oil. But during the burning process, you also generate CO2, which creates miscibility conditions with the oil. So there are many benefits, but it's a difficult process to control and certainly also to model. I know that air injection is being carried out in India, various places. And it can also be applied to light oils. The most famous example is in the US, It's called the buffalo field. So the final slide on the basics of EUR is one that I got inspired by from called the pyramid of trust. It shows a timeline and the most important parts of the planning process for an EOR flood. So you start with lab work, rocks and fluids testing. Then you move on to single well chemical tracer test, where you try to understand residual oil saturation and injectivity in the near wellbore area of a single well. Once you are confident that that you are able to reduce the oil saturation, then you can move on to an interwell field trial. And then finally, you would go into full field or pattern-based deployment. And you can see that the cost increases gradually. So don't cut down on the lab work, because that's actually the cheap part. Moving on to the latest advances in EOR, I would highlight two main topics. The first one is foam for improved conformance. And foam consists of a little bit of surfactant that creates, it encapsulates the gas phase in small bubbles. So it's like hitting the brake on gas injection, so that you don't get early gas breakthrough. It doesn't take that much surfactant. You only need to inject a small slug, and you can combine it with a WAG flood. The problem is that the foam is destabilized when it sees oil. On the next slide, we have another promising EOR method, which is called low salinity or smart water. And this was pioneered by BP. It was not invented by BP, but it has been certainly pioneered by BP. And the idea is that you inject a water with a much lower salinity, typically between 2,000 and 5,000 ppm, and thereby you are able to change the wettability of the rock from oil wet or mixed wet towards slightly water wet. And the way it works is that you have clay swelling, and you have expansion of what is called a diffuse layer or double layer, which induces release of oil bound to the surface. Moving on to the next slide, people have also tried to implement this idea in carbonates, but the mechanism is very different. A lot of work has been done in Norway on chalk, where it appears that you need some divalent ions, calcium, magnesium, and then sulfate acts like a catalyst for the ion exchange between surface-bound calcium and magnesium in the water phase. The temperature must be higher than 90 degrees, so there is in order for the kinetics to work. And it doesn't work on all carbonates, unfortunately. So low salinity is not just about reducing salinity, it's about playing with the ions. And you must make lots of experiments before you find the right cocktail, the right mix. But it's a fairly inexpensive method. So if we look at other EOR methods in development, there's a lot of work going on with viscoelastic surfactants. Surfactants are also being developed for modifying wettability in oil-wet carbonates. Some companies, such as Wintershall in Germany, have designed biopolymers because they are more salinity tolerant. There are research that look at nanoparticles for foam stabilization, mainly, but also for magnetic heating or reservoir surveillance. Then you have new applicabilities of microbial EOR for reducing interfacial tension. One of those companies is Glory Oil. There are also people looking at enzymes which are, let's say, made by microbes, but you don't inject the microbe, you just inject the product. People are also looking at hybrid methods where you combine low salinity and polymer, for instance, because it turns out that the polymer requirement is reduced substantially when you lower the salinity. And finally, I would say that people are looking at expanding the operational envelope, both for gas injection and polymer injection, to target heavier oil types. The next topic is on monitoring and surveillance. And the main purpose is to make sure that the EOR process performs as expected. And how do you know what to expect? Well, you have to construct a reservoir simulation model and create a forecast. Both for the EOR flood, but also for what is called the baseline case, which would be a water flood or a do nothing. So what would you have done if you did not implement the EOR? And from these curves, you derive an incremental oil profile that you compare against actual performance. So during a pilot phase, what you're interested in is to reduce uncertainty that have the biggest impact on the economics. So you must be able to measure or infer residual oil saturation. You must get a good handle on injectivity. You have to make sure that you will not get early breakthrough. So heterogeneity should harming your process too much. And you have to understand if there are any operational constraints. Furthermore, if there are problems, you have to be able to intervene. So if you get early breakthrough, to be able to shut off either mechanically or chemically, either gas or water. So examples of monitoring techniques are the same as for a normal field development. You can have observation wells, you can do saturation logs, production logging, coring, sampling of produced fluids, and so on. At the field scale, 4D seismics is mainly useful for water flooding. You can do tracer experiments, and you can also do electromagnetic cross-well imaging between two wells. I would say one of the most important tools in monitoring is a reservoir simulation model. So a quick example of an analytical monitoring technique is from Prudhoe Bay, and it's called a diagnostics plot, where you plot what is called the utilization factor for this gas flood, and that's defined as incremental oil divided by volume of injectant. And you plot that over time for different patterns. And this is actually a fair comparison between patterns that can have different sizes. So that's an example of a metric that you can use between patterns and also between fields. The next topic is on completion challenges. And as I mentioned briefly before, most EOR methods are implemented in mature fields. So the wells were most likely for an EOR flood. They were designed for depletion or water flood cases. Typically, you would have insufficient zonal control, either because it's an open hole completion or because there is no longer any zonal control. If you have a bad cement job and you have flow behind casing, for instance. Also, the metallurgy may not have been designed with EOR in mind. I know that Holger will come back to that in a minute, because well integrity is a major threat to an EOR project. If you go offshore, it can sometimes be difficult to even get access to the wellhead, and workovers can be very costly. So if you are so lucky that you can plan an EOR flood in a greenfield, you would need carefully about the well placement. You would need to consider zonal isolation. So both monitoring and also the ability to intervene. Well integrity is very important, especially for gas injection. And then, of course, the metallurgy has to be corrosion resistant and rated to high pressure and temperature. For WAG, you need to be able to switch between gas and water. So the ideal situation is if you have separate flow lines for each injectant. In many cases you don't, and it imposes an additional effort on the operator. For polymers, you need to be careful with the chokes because it can reduce the viscosity of the polymer. So the final two slides, it's just examples of some leading EOR subsurface specialists in academia and some books on various aspects of PVT, gas injection, and general EOR. So now I would like to pass on the mic to Holger Kinzel.
Thank you very much, Christian, for your excellent presentation. And I'm not one of the group of EOR specialists that published a book, but I published a lot of other papers. And in my 30-plus year career, I have dealt a lot with well integrity. Well, in former times, well integrity was always mentioned. We have a standard, or we have various standards on that. I like the definition of the well integrity of the NORSOC standard, of the Norwegian one, on the D010. And it is defined in a way that it says, the application of technical, operational, and organizational solutions to reduce the risk of uncontrolled flow, so of formation fluids in well road. And here comes the key word, which also Christian mentioned, throughout the life cycle of the well. And that is important. So, on the next slide, if we talk about well integrity, the well integrity is formed of various well barriers. So, a well barrier can be anything that prevents the fluid from unintentionally flowing into the wellbore, or, as Christian also mentioned, a cross flow behind the casing. Now, with that in mind, the well barrier can be any kind of hardware, like the casing, or it can be the fluid in the well, but it can also be the formation. And as Christian mentioned, we are doing a lot with the formation. We're injecting something, we're injecting steam, so we create a different environment for the formation itself. And in the next slide, we shall see what a well barrier element consists of. And a well barrier could be any element that does prevent flow in combination with other well barrier elements. So the formation itself is one important well barrier element. Of course, we have casing, we have packers, we have the cement, so we have a lot of elements in the well. And now, as Christian mentioned, these are usually not designed for what we are doing with it. It's not designed for EOR. So if we go to the next slide, there's two important well barrier elements that are they cannot be replaced. I mean, we can replace a completion, we can pull a tubing, we can change a packer, we can do a lot, but there's two things that are basically there. It's the casing, so the tubulars, and the cement. So those are two of the well barrier elements we need to look at when we plan to do an EOR operation. The next slide shows, and Christian also already mentioned that in one of his slides, look at what your casing is made of. Of course, it's the pipe itself, but it's the connection. So if you plan to do something with a connection, you pump steam, you pump something that probably the connection is not being designed for. If your tubular connection is depending on thread compounds for leak tightness, such as any API ground or buttress, any tightness is only temporary. And when I heat it up, when I pump something so it is not designed for, this time can be very short. Also, something on the next slide was already mentioned by Christian. Look at what your pipe is made of. Is it really designed for the high temperature or temperature variations? We are injecting, we are producing, we are producing wells into injectors and vice versa. We are pumping corrosive fluids such as CO2, and on the left-hand side you can see some of the tubulars that were retrieved from wells that have been exposed to those high corrosion environments. So make sure that your steel is designed in the right way for what you plan to do it. Also, on the next slide, what we see is same thing with the cement. Do we know what cyclic loads my cement will see throughout the lifetime of the well? If you cyclically load the cement, load, no load, the lifetime of the cement is limited. This can be simulated today. There are programs, there are ways you can simulate that. You can go through the lifetime cycle of the cement and predict if the cement would still fulfill what it is designed for. If you don't do that, you might lose your integrity of the well, and you might have problems. Next slide shows what to expect. I mean, it's like a building. Usually a building we build for a certain lifetime. A bridge is not built for a certain lifetime, same as a well. We assume it might last for 25 or 50 years. We have wells here in Germany, they already produce since over 50 years, 60 years. Now, after this long lifetime, what we try with EOR, of course, is to increase the production, increase the lifetime of the well. So we should plan for that. We should be sure that we say, whatever we do to the well, we need to make sure that the lifetime of the well is not ending at that point, but that it will survive any EOR measures we do. I only raised a few questions. I couldn't give you a lot of answers, but I hope I raised a little bit of, or I triggered a little bit of your engineering thinking when you plan an EOR well, what to think about and what to plan ahead. So the next in our round is Rajesh Sharma. He's an expert on production performance for E&P, and he will lead us further through our session today. Thank you very much.
Thank you, Holger. This is Rajesh Sharma. Uh, Thank you, Holger and Dr. Christian, for setting the context for me. Two important takeaway for me from their presentation is that there has to be early deployment of EOR right in the beginning of the field development, for which we need to set up a multidisciplinary team comprising the geoscientists, the engineers, and a data scientist. This team would actually be, be defining the needs and setting up the processes. Yeah, uh, for for the digital oil field. Uh, Another point, what Holger has mentioned, is about the well integrity. I would like to assure both Holger and Dr. Christian is that with my experience in setting up digital oil fields for the conventional production, uh, the industry is already mature enough in identifying the tools and the processes and the systems where a collaborative environment today exists for the for acquiring the data, cleansing it, allocations, analytics, making the running the reservoir models. So what needs to be done is that what we'll have to raise the bar and make certain changes or improvements in each of the respective areas to suit the enhanced oil recovery. Uh, that can happen through the workflow automation on the top of it. In the next slides, I would be talking about what are the actionable points. I can just touch upon it. The few of them, as I said, there has to be some enhancements by way of enhanced imaging of reservoirs, use of 4D seismic, smart injector and producer wells, controlled multilateral drain holes, tools and workflows required to be developed for screening of the ER techniques. There's certain companies like Schlumberger and other who have already developed certain tools in this area. And as I said, intelligent wells with smarter sensors, especially for the artificial lift and automated model building capabilities, seamless data transfer. In the next few slides, I'll be again talking about uh, what where we are and needs to be done. Uh, just give you a quick recap of the building the digital solution today. As I said, this collaborative team, which will be set up right in the beginning, will ensure that the development engineers give them the right tools, technologies, processes, and they give them the right softwares. Like some of them I've gone through the web is a Petrel platform, Intersect High Reservoir Simulator, the Digital Rocks. You keep hearing these, which are already being initiatives being taken up in the industry. As Dr. Christian also mentioned about single well-based electromagnetic sensor, yes, these are all required. We also need big data analytics to support all this with like Hadoop, R, Python, and other applications and programming languages. All this put together, we will have to develop as one collaborative platform, and the solution will depend upon the different assets and the fields together. Well integrity is very important, which is of course being done through a constant surveillance, and it will become all the more important as we go for more and more gas injection and other recovery methods which are going to be deployed. I think I'm leaving you with this just a food for thought that there are technologies being developed, improvements being done, and there is a lot to look forward to, which will help in screening the right EOR technology. With this, I would like to hand over to my fellow presenter Anindra to give us a perspective about what are the experiences of EOR. by the industry. Over to you, Ananda.
Well, thank you, Rajesh. Here
Okay.
at the onset, I just want to give a brief overview of what are the hello.
Yes,
Yes.
sir.
Yeah. What are the EOR processes that are being currently practiced in worldwide? Now, coming to the slide, please. That, but I will not talk about much on that each and every process that Dr. Christian has already talked comprehensively. So I jump upon my topic on how to screen it. In the next slide, you will see that there are global criteria to how to screen it. In the left figure, you can see that historically there was a historically there was a try to categorize or screen it through oil gravity, but it has like overlapping region, so we cannot pinpoint or zeroing down to specific process. So this problem is somewhat been mitigated in the right figure, where we have plotted versus depth. Here it is, from this figure, it is emerging out that steam injection is only applicable to shallow depth and heavy oil, and whereas the chemical flood has better window of a larger window. So this helped us to identify where and where is our reservoir, what is the character of oil, and how we can choose for our EOR techniques. But these are very global, and I will touch upon in the next slides on what specific EOR specific criteria that needs to be taken, needs to be considered before choosing anything. Okay, in this slide I have given the what are the criteria that should be met for chemical EOR. The up and down arrow shows the top and bottom values of each specific criteria. Here I want to make a question to the audience. I want to have a view to the audience that in case of alkaline flooding, the ROS means residual oil saturation changes by reducing IFT and the viscosity of the oil. But in polymer flooding, the ROS does not change. So it will be interesting to know from the audience, since ROS is not changing, so can we technically classify polymer flood as tertiary recovery process?
Ananda, we have the audience polls with
Yeah.
us. Would like to share you for a few seconds. Can you see that? This is what our audience is
Okay.
saying.
Okay.
89%
Okay.
says
Okay.
yes and 11% says no.
Okay. So it is interesting to know, but what I personally believe, polymer injection cannot be grouped into tertiary process because it is somewhat the upper hand of the water injection. So coming to Indian chemical EOR, what we in Mangla field, due to heavy oil viscosity, we have applied it and pilot was successful. We can see that in water cut has decreased and oil rate has increased. In Sanan field also, because of high mobility contrast, this polymer flooding has been applied and there is an increase in oil rate of 300%. In Viraj field, due to high acid number of the crude, ASP flooding has been applied and that was a success. So keeping in success in mind, Kalol and Jalora was the in pipeline. And Kiran India has planned for ASP flooding from Mangla, Bhagyam and Aishwarya field. In the next slide, we will see what are the criteria of thermal EOR. In case of thermal, as my fellow speaker already told in detail, we hit the reservoir, reduce the viscosity, we produce the oil. So it is somewhat, and also in the previous slide we have seen that it is it's constricted to the shallow depth only. And here in situ combustion, shallow depth. Now let us come to Indian application where we have applied. Balol, in case of Santhal field of ONGC, we have applied. Balol field is a very highly porous and permeable formation. Its permeability in the Dasi and depth is very shallow, around 1000 meter. In Balol, I'm just sharing a single well. After its application, The oil rate has come in 700 commercial PPT from a single well. And the same success story is repeated in the Santhal also, where oil rate has increased to 1200 barrels per day, and what considerable decrease in the water. So this is the success story of these two fields. And based on two field success, Lanwa, which is also in the nearby area, we have planned for in situ conversion. Next, I will talk about what are the criteria of selecting gas flooding. The basic theme of gas flooding is to, or the basic purpose, gas flood is having very high microscopic displacement. So it is suitable for tight reservoir and lighter oil. And this technique is still that we can use in carbonate also. Now coming to this Indian application, in Gandhar field, we have applied it both immiscible and miscible gas flooding, where the depth of reservoir is at 2900 meter, and minimum miscible pressure was 350 ksc, which this thing will be shown on the next slide. That yes, and after application of miscible gas flood, the incremental oil rate was 4,000 barrel per day, and which results of increment of oil recovery of around 22%, which is quite a good. Now swag, we have already planned it one of the Western Indian offshore field, which is carbonate, with whose results is yet to become, which is we have planned it till date. Now next, which is the more interesting topic, is MUR, microbial UR. In microbial UR, what we do, we send the microbes and nutrients simultaneously in half and puff method. Within the reservoir, due to metabolic action of the microbes, acid and gas is generated. Acid reduces the porosity and increases the porosity and permeability of the formation. Gas increases the pore pressure and reduces the viscosity of the oil. So oil mobility has increased and we get better oil. Coming to this Indian context, on the next slide, that we will see that we have in ONGC and in Oil India Limited, we have applied. Oil India has applied this MUR in its Duliajan field, which is situated on the northeast part of India. I am just sharing one case. The well which is showing on the left figure is producing very suboptimally. We have applied MUR and water gas has decreased. And oil rate though increased a little, but there is an increase. But this is still under R&D stage. We have to do a lot of study. Okay, until now, whatever I have discussed to do is only the success story, but no fact is complete without a failure. So make any story success, we have to have a rigorous lab testing and pilot testing. So then only we can have success. Now with this, I am concluding my part and I am requesting Dr. Christian to please carry on the proceedings further. Thank you.
Thank you very much, Aninda.
Dr. Christian? Sorry to interrupt.
Yes.
Yeah, we have two people in the audience that are very impatiently waiting for your answers. Can I allow them to unmute and ask you two questions? Just two questions.
Of course.
Okay. James, are you there? James was telling me to unmute him so that he can ask you a question since 15 minutes. Okay, Ankit.
Okay, sure.
So I'll just unmute Ankit and James. Ankit?
Yeah, hi, Doctor. Yeah, hi, Namrata.
Yeah, hi, Ankit. You may ask your question, please.
Yeah, hi, Dr. Christian. Thank you for the beautiful enlightenment. First of all, my question is that what is the best EOR technique which is used nowadays across the globe?
Oh, that's a million dollar question. I would say if you have gas available, then gas injection will work in many reservoirs.
Okay.
Chemicals are typically more expensive, and it's more difficult to model. I think gas injection is fairly well understood, but it's clear that if you have a heavy oil situation, then you may have to go to thermal methods. I think when you look at worldwide EOR production, I think it's coming either from gas or from thermal. I think the chemical EOR contribution is fairly limited.
Okay, that means mostly the major being used by the gas injection.
Yeah, and the vast majority of that comes from the US.
Yes.
Okay. Thank you, Dr. Christian.
And
Thank you,
the
Ankit.
second question, I
Ankit,
remember the question.
will you mail
Just
your
second question.
answer?
It's
We'll mail you the answers.
it's a short question.
Okay.
It's just short question, as in EOR
Okay.
technique which is used in high pressure and high temperature wells.
I don't think that there are any EOR methods used in HPHT, but you have to bear in mind that when you implement gas injection, you need to have a higher injection pressure.
Yeah.
Okay. Thank you, Ankit. So, Dr. Christian, this is the last question I'll take from James. Yeah, James, you may go ahead. Shoot. James, your turn. Okay. So he was waiting since 15 minutes to have an answer from you. So, okay, Dr. Christian, we may go ahead with the summary.
Okay, but in any case, you're welcome to send all your questions, and I will get back to you on email. So, in summary, I would say, of course, the initial screening phase is very important, and we saw some screening criteria in this presentation here. It's important to understand what controls the current recovery factor. Why are you not seeing 70% recovery from your water flood or depletion case? Because that will really guide your selection of the most appropriate EOR method, provided that you have access to the injectants. So no EOR method is perfect. There is still life after EOR, I would say. The best methods will recover maybe 15% of the oil in place. And if it's a gas project, you would need to look at a foam assisted WAG to help mitigate some of the gas breakthrough. So there are some emerging methods that are worth looking at. In terms of planning, you can never plan enough, but you have to realize that EOR projects are complicated, and the economics are more tight, especially now. So spend the money on lab work and field trials to avoid costly failures when you do full field implementations. I mean, there are always things that will go wrong, but try to limit the economic exposure. Don't cut too many corners. So in terms of implementation, you need a clear monitoring strategy. You need to understand and prove that this actually works. You need to have some quantitative metrics of how a particular pattern performs and compared to an expectation case. So that leads us to data management strategy. You must measure something and you must store this data. You have it accessible and analyze it. Safety aspects are also very important. Holger touched upon well integrity. cannot be ignored, especially not for gas injection projects. And I would say technically it's complicated, but organizationally is probably one of the biggest challenges. I think it's very important, as it was mentioned, to build a collaborative environment, because this requires help from many, many people. And everybody has to understand why this project is important and what's in it, how they can contribute. The chain is never stronger than the weakest link. And if the operator doesn't understand what you're doing, then all your planning work is useless, right? So with these words, I would conclude the summary. So I hope you enjoyed it. Thank you very much.
It was such a wonderful session, Dr. Christian, and this is such true words. I'll finish this session with this question from James because I announced that. So I'll read on his behalf because he has self-muted himself and he's not able to ask. He has given me this question in parts, so correct me if I'm wrong. In regards to well control using analysts for gas injection, what is considered versus running a smaller OD tubing of coil tubing to run gas lift system covering well integrity or tubing within tubing to keep one barrier?
I'm not sure I understand the question.
Okay, fine. So no problem. We'll mail him the answer. I'm just announcing this question so that people get to know about it.
Sorry, James. I need to see this in writing, and then I'll need to think about it.
Okay.
Me too. I just heard something about a one-well barrier, so that is something I strongly discourage. So whatever the operation is, the two-barrier principle should always be observed, so whatever it is.
Oh, I have sent the question to all the panelists and organizers. They may see there on their screen.
Hey, gents, can you hear me now?
Yes, you are audible.
Hi there. Sorry, for some reason it muted and it wouldn't unmute itself. Yeah, just regarding that question, I'm talking about single bore, not non-dual bore or non-two well for injection, using the same well for either jet lifting or artificial lift using gas lift with in the hole. Some locations, some countries have, you know, they're injecting down the annulus and using the gas lift valve and then producing up through the tubing. My question is obviously that there was a new SPE paper using cool tubing and running that within an existing well, so after depleted and trying to change and using an EOR technique. My question is, why do some of these countries still go ahead and use the annulus for the gas lift